So for part A, we need to find a formula for the spring constant in terms of the Young's modulus. So we can say that the Young's modulus equals stress over strain. This would be for part A. We know that the stress is simply a force over an area, and the strain would be the change in length over the original length. However, it's 1 over strain, so we'd have to flip that. And so we find that the force is going to be equal to the Young's modulus times the area times the change in length divided by the original length. And so if we wanted to find the Hooke's, by Hooke's law, we know that the force is going to be equal to kx, where here x equals the change in length. So here, essentially, x and the change in length cancel out, and we have that k, the spring constant, is going to be equal to ya over the original length. So this would be your answer for part A. And then for part B, we want to find the spring constant in terms of, we need to solve for the area. So we can say that the spring constant is equaling the Young's modulus times the area divided by the original length. This would be equal to y times pi r squared divided by the original length. And we know that the radius is half of the diameter. So this would be 1.291 millimeters over 2. So the radius is going to be equal to 6.455 times 10 to the negative 4th meters. So the spring constant is going to be equal to pi times 6.455 times 10 to the negative 4th meters squared times the Young's modulus, 10 to the 10th pascals, divided by the original length of 0.750 meters. And we find that K, the spring constant, is going to be 1.9 times 10 to the 5th newtons per meter. So this would be your final answer for part B. And then for part C, they want us to find the force. This is going to be equal to the weight, and this would be equal to the kx. So this would be equal to the spring constant that we found in part B, 1.9 times 10 to the 5th newtons per meter, times the change in length, or 1.25 times 10 to the negative 3rd meters. The force here would be equal to 237.5 newtons. So this would be our force. That is the end of the solution. Thank you for watching.